Hi, this is Mr. Hodgen. We're going to be doing the Chapter 8 test review. Let's get started. This is available on School Loop, and everybody was handed out one copy of this during class today, on Tuesday, February 11th. Okay, so let's get started. Which polynomial is prime? Okay, so what does prime mean? So a prime number, such as 11, means it only has factors of 1 and itself, as opposed to like the number 10 that has other factors such as 2 times 5. So a prime number is 1 in itself, so a prime polynomial is the same idea, only 1 and itself divide into it. In other words, you're not able to break it down into smaller pieces. Like 11, we can't break it into two other numbers, it's just 11 times 1. So whereas something that's not prime, we can't break it into two other things being multiplied. So such as, let's see, let's start at the bottom. If we were to go ahead and factor this, can we break this up a little bit? Okay, we should be able to. We can do this using the box, or I can just factor out a 3x out of the first two terms, and then also a -1 out of the second two terms. Alright, so we can rewrite this as 3x minus 1 and x plus 5. Another way to do this is using the box. Put all those terms into the box, and you'll end up with the same two answers. Okay. Here we can simplify this. If we have 3xy's and 5 more xy's, altogether you have 8xy's. And b, we can again factor that. Two numbers that multiply to 6 and add to 5 are 2 and 3. And there we go. And last we get here, I did this one last on purpose, because we cannot rewrite this as two other things being multiplied. The only thing I can do is write this as 1 times x squared plus 25, which is back to the number 11 is what the definition of a prime is. So I can't write this any other way. Some of you might be looking at this saying, but that's 1 and that's 25, those are perfect squares, but remember you need a difference. So this is addition, so this does not factor. So A will be our answer number 1. Speaking of the box, we're using the big X. Remember we have this big X. We called this the attic basement method. Okay, so if we had the term ax squared plus bx plus c, okay, we can take the a and the c, multiply them together, put that right here, and we can take the b term and put that down here, and we find two numbers that multiply to the AC and add to the B. Okay, and when do you use it? Well, it's when you have this format right here. So the main question is use it when factoring a trinomial. Okay, and the root here, prefix tri, kind of gives away. That's 3 terms. Okay. Hence this right here has 3 terms. It has the A term, the B term, and the C term, 3 terms. All right. It's helpful because when using the box method, or actually any of the other methods, we usually put the A term here, the C term here, but our B term, we need to break it up into 2 parts to go here and here. So we use it to break it up, and that way we can use the box or some other methods and factor it. Okay. So it helps us factor trinomials. Okay. Create a polynomial that we considered a difference of squares. Okay, squares, remember we're referring to perfect squares. Okay, perfect. So we're talking about numbers such as 1, 4, 9, 16, 25. We've seen these in class every day. Okay. 64, 81, 100. They go on, and these are just simply 1 squared, 2 squared, 3 squared, 4 squared, and so on. So those are the perfect squares. So you're looking for these numbers when you're factoring a difference of squares. And again, the other word here is difference. That just means subtraction. Subtraction. So we need to be subtracting just two of these types of numbers. I can pick any of them. I'm going to pick, let's just 9 and 81, or 64. With that. And usually the first one has a variable on it. So that's squared or to the 4th power. It's important that this exponent is even. Okay, that has to be even. So that would just simply factor. It doesn't tell you to factor it, but if we did factor it, here's what it would look like. 9n squared is 3n times 3n. 64 is 8 times 8. In order to get the negative, or the subtraction, you need a positive and a negative. So a positive times a negative is the negative. Which one is a perfect square trinomial? So perfect square trinomial, what does that mean? Those are the ones that where these two are the same. Okay. These are the same. And we can write it as that one binomial squared, because they're the same, so it's anything times itself is just that thing squared. So which one of these are asking can you write where the two binomials after you factor it are the same, and therefore we can write it as just one binomial squared. Okay, we can go through a lot of these. We'll cut to the chase with it, and we'll see that after enough trial and error, that b comes out to x plus 5 and x plus 5, which is the same as x plus 5 squared. Alright, let's go over to column 2, number 5. There we go. Which binomial is a factor? Okay, so we need to find, always start with GCFs. Okay. Always start with GCFs. If you're ever lost and not sure what this means, you know step 1 is always look for the GCF. So what number goes into both of these? 2 and 32, that would be just 2. And is there the same variable in both? And you can see, yes, there's an n here, n squared here, and an n, so we can take that out. Let's go ahead and see what's left over. So 2n times n is 2n squared. 2n times what is negative 32? That would be just 16. Alright, and then you can see, binomial, okay, prefix 2 terms. Okay, and we see here we have two factors here. One of them is a monomial, one of them is a binomial. I'm talking about the one with 2 terms. Factor completely all the way. So again, first step, GCF. Got to do that every single time. So what number goes into all of them? I see a 2. Is there a variable in all of them? No, there's no k in the last one, so just the 2. See what's left over. And, okay, my mission is to try to factor this. If it does, and my answer will look like this. Gotta leave the GCF in front, so I'll leave it there. So here's where we go to, since we looked over here, when do we use that big X? Factoring 3 terms, trinomial. So we have 3 terms, let's try to factor it, big X. So multiplies to 3k times 8, 24, k squared, adds to 10. So what two numbers multiply to 24 and add to 10? Okay. Let's see here. Factors of 24. Let's see, I think 3 and 8. But 3 plus 8, 3 minus 8, that doesn't equal 10. And then another factor would be 6 and 4. And then 6 plus 4 does equal 10. So I'm going to use 4k and 6k. Now let's draw a better box than that. And we got a goes in here, so we got 3k squared. C goes in the last. So two terms, 4k and 6k. Want to factor this? GCF on the first row, they just have a k in common. GCF on the first column, they have a k in common as well, but they also have a 3. And of course, check it, k times 3k is 3k squared. K times what? It's 4k plus 4. And 4 times what is 8? 2. And 2 is also the GCF of the bottom row. So we have a 3k plus 4 and a k plus 1. And if we k plus 1, and if we multiply that all together, multiply this back together, we'll get this. And when we distribute that 2, we'll get the original. So your final answer, whatever you put down, should multiply back to the original. Remember, we're just doing all this multiplication backwards. That's what factoring is. Oh, now we get to choose. This is answer... Oh, I'm sorry. That is answer 2. Yeah, so this is answer... Let's see here. A. If you didn't do the GCF, you probably got answer B. So notice if you multiply this back in, you can end up with 6k plus 8. So you got to get that GCF out. Alright, factor. So, okay, so GCF time. Every time. First step, GCF. Alright, so what number goes into all of these? 4, 12, and 36. That would be just 4. And then, is there any variables in all of them? So I have an a squared, an a, and an a. So yes, there's an a in all of them. What about the b's? Yeah, there's also a b in all of them. So I've got quite a big GCF here. Okay, so we got 3 terms on the inside. So each of these, I'm going to take away, or take out, divide out, a 4, an a, and a b. So the first term, if I remove the 4, remove an a, and remove a b, you're just left with a. The second term, if I remove a 4, I'm left with -3. And an a and a b, I'll be left with 1b. Lastly, if I remove a 4 from 36, I'll have a 9, positive, and an a and a b are removed, so that will be it. And if you look at the inside, this isn't anything that's factorable. We have 2 different variables. One of them isn't squared, so that is as far as we can go. Okay? There's no x to be done because we have different variables, and we need the first one to be squared anyway to use the x. All right, number 8. First step, guess what? GCF. So what number goes into both of these? 3. What about variables? Yeah, there's lots of x's. X to the 5th, x to the 3rd, so they both at least have 3. Let's see what's left over. Take a 3 out, there's nothing left. Take 3 x's out, there's 5 total, you take 3 out, you have 2 left over. Take a 3 out of 75, left with a 25. And if you take 3 x's out, there's no x's left over. Alright, question is, can we factor inside the parentheses more? And you might notice that this relates directly to a question earlier about running a difference of squares. So whenever you see these numbers, it's not a coincidence. Think of it as a gift, and it's something to make things go faster. So yeah, we have 1 and 25, both perfect squares. So we're going to try to factor this even more. Okay, so what 2 numbers multiply to x squared? It's just x and x. And what 2 numbers multiply to 25? It's just 5 and 5. And to get the negative, we need a positive times a negative. There we go, factored completely. that's into side 1. Let's go to the back. So we'll do a little bit more of the same thing, just get more practice. Okay, completely factor. Let's completely factor. Where are we? Okay, over here. Already have 4 terms. Looks a little unusual, but we're going to try our usual methods anyway. So even if you get a problem that doesn't look like some of the others, it does have one of the main characteristics, and it has 4 terms. So we're going to do the same thing we always do when we have 4 terms: 1, 2, 3, and 4. I'm going to put it in the box, 4 square box. And find the GCF of each row and column. So is there anything these have in common? Say 3 and a 6, they both have a 3, and they both have a y, so there we go. Anything that the first column has in common? The numbers, not really, but the variables, yeah, they both have an x, and you can see that 3y times x equals 3xy. And from here, same process, 3y times what is 6y? So that would be 3 times 2. Positive 2. And 3 times what would be negative 8? Negative 4. And negative 4 is also the GCF of this row. Notice how they both have a negative. So we do have a negative in the GCF. Something in common. GCF is just whatever is the same. Alright, so our final answer will be 3y minus 4. And of course the order here doesn't matter. You could put x plus 2 first. So order's okay because 2 times 3 is the same as 3 times 2. So it's okay. We're just multiplying. Alright, we have 3 terms, so use the big X. Add it. A times C is 42. And basement, negative 13n. I forgot the variable up there, so that's 42n squared. So what 2 numbers multiply to 42 and add to negative 13? Remember, don't say 6 and 7. It'd be negative 6 and negative 7n. So they multiply to positive 42 and they add to negative 13. Okay. Now we have our box. N squared, first term is always in the first box, last term is always in the last box. And the whole reason we did the x, now we can fill it out. And negative 6. Same process as the prior problem, GCFs all around. And then n times what is negative 6n, n times what is negative 7n, and then check it, negative 7 times negative 6 does equal positive 42. So that equals, in any order, n minus 6, n minus 7. And then 11, look for a GCF. Is anything going to 36 and 49? I can't think of anything, so next step. Hopefully you saw the red flag here. 36 and 49. Both perfect squares. This is 6 squared, and this is 7 squared. So this will be just a quick factoring, no work to even show. 36m squared is 6 times 6, okay, 6m times 6m. And to get the 49, we need a 7 and a 7. And to get the negative, we need a positive and a negative. That's it. It's so nice when we get these. Lastly, keep going. Alright, GCF. Kind of an odd problem. There's a little bit going on here. We could look for our GCFs. You can always do that. You'll notice they do not have a number in common, but they do have an A in common. Okay? So we could do that. We might be worried about having a negative in front, so why don't we just take out a negative? Usually in the front we don't want a negative. So see, when I take out that negative, I'll have a positive 2a. Take out a negative, I'll have a positive 11b. Take out the negative a minus 21b. Okay. And these happen to be the same variable. This doesn't usually happen in our routine problems, but it does happen here. That if they're the same variable, remember we can just combine these together. So we have 2a, that's can't do anything with that, but these are the same variable. So 11 minus 21 would be negative 10b. I'm just going to leave that negative a in front. And that's all we can really do here. The different variables really is what let me know that we're not really doing anything else. There's no x, there's no other shortcut. Oh, well, actually now I think about it, I do see. Now we have a GCF of 2. So actually I'm going to go ahead and take that 2 out as well. Yeah, doesn't hurt to keep on going. So yeah, if I would have combined these in the very beginning and made negative 10ab, we would have had that 2 in the beginning. But it's a good lesson right here is that your final answer, what caught my eye is that, wait a minute, the thing inside the parentheses has a GCF. I'm not finished. That was a, okay, that was a red flag for me. Here's my red flag, okay? Red flag. That I was not finished. There's a GCF there. Had to keep going. Here we go. All right, 13, very similar to number 11. 36, 49, 100, and we got 1 here, and it is a difference. So 100, what perfect square would that be? Hopefully you get 10 times 10. And then w squared would just be w times w. And to get the negative, we need a positive and a negative. That's all there is to it. Love those ones, nice and fast. All right, and let's finish up just the last part. Let's see here. Going up. Oh, bonus. Okay. We can do the bonus. Again, red flag again. Look at that. 25 and 36. Perfect squares. Not by coincidence. Please watch out for them. Alright, so I'm going to try this. So we got 25W, 5W, 5W. We have 36. That's 6 and 6. Now this time, we do have a middle term, which is negative. So we're going to try negative and negative and see what happens. Two negatives will add up to a negative, but these two negatives will multiply to the positive 36. I do have to check, though, do these factors right here add up to this? Okay. So the first one, 5W and negative 6, is negative 30W. And the second one is the same, negative 30W. That does make the 60W. So this is a good answer. So I don't want you to think that, just because it's perfect squares on both sides, that it has to work this way. Alright, so I can pick any other number. Let's just say if I put 61W, right? And I tried to do this, it would not add up, alright? So if it doesn't add up, we'd have to try the X or some other method. Also, you might remember that from the front side, these are the same, right? So I can write it like this. That's fine too. Lastly, we have a area problem, alright? And we're talking about rectangles. I'm going to draw it out like this chest. You might recall that the area equals the length times width. So they're saying the whole area, okay, is y squared minus 8y plus 15. Okay. Which expression represents a possible length for the rectangle? Okay. So we're trying to figure out, this is the length, this is the width, which two multiply to our area. Alright. So could y plus 5 possibly be a length? Meaning, does y plus 5 times something equal this? Well, let's just go ahead and see, well, what does this factor to? Let's try that out. So what two numbers multiply to, let's see here, 15y squared and add to negative 8y? And we'll see, okay, that's be negative 3 and y and negative 5y. Alright, if we went ahead and did our box, we'd end up with, yeah, that's y minus 3 and y plus, or y minus 5. And going down the list, we can see, yeah. So it's a word problem, right? And I did a lot of talking, but in the end, really, what was the work? Okay, if I remove all this, and I remove the idea of area, what do we just do? Okay, it's basically the same thing as every other problem. So sometimes word problems can seem more difficult, right? But if you look at everything else we just did, like number 10, we got a trinomial, we factored it, right? And what was this word problem? Well, they gave us a trinomial, I factored it, and I got an answer. So sometimes the words can, build a picture, but in the end you just end up doing the same thing you would do even if there was no words. Hopefully that would give you a little more confidence with some of these word problems. Alright, again, your goal is to be able to do this entire review, beginning and the end, without stopping, and get 100%. And if you do that, you'll be very well prepared for your test. Good luck.